In this video, I'll be setting up the hydraulic prototypes that will be used for the cross-section feature definitions. The cross-section feature definitions are going to be used when you're laying out channels and ditches. Ditches are a little bit different than pipes. When you think about pipes, those are always going to be a quantifiable object, whereas a ditch can be a physical object if it's concrete lined or maybe with riprap. But if we think about a typical ditch that is just natural with either dirt or grass lined, those are not going to be physical objects that show up in the plans and inside of the quantities. If we're laying out a ditch, then attributes that are defined in the cross-section nodes are not going to be used. Primarily, those cross-section nodes are just going to be used so that you can specify a new XY coordinate where the ditch is going to change horizontally or vertically. We can also accept additional flow at areas, or if we need to change the ditch cross-section. So where the ditches are going to define their own cross-sectional attributes, if we're using a channel, then those are going to purely rely on the information from the cross-section nodes. Right, so moving back down to the cross-section nodes, we're going to be creating a hydraulic prototype for each one of these feature definitions that we have. So I'll go ahead and start by right-clicking and creating a new prototype. And when we set these prototypes up, the main thing we're going to be focusing on is the physical section. So when these are placed, it's going to be storing an X, Y, and Z position for all of these. And then we're also going to be specifying what that cross-section type is and the cross-sectional attributes for that cross-section. So we do have a conduit catalog that has all of these ditch sections set up already. So I'm going to set the cross-section type to cross-section catalog. I'll pick my catalog class, which is going to be for a concrete flat bottom, and then go ahead and specify the size, which is going to be the 2x1, 2:1. The last thing I'm going to set up is the transition type. This is going to be used when we're using channels, but when we are connecting channels to the cross-section nodes, we can choose how it's going to transition. So we can either say that we want it to transition gradually or abruptly. So gradually is going to be a linear transition, and then abruptly is going to just at the very end of that channel section when we're connecting into that cross-section node, it's going to shift the cross-sectional attributes to that new size that we're choosing. So you can make that choice here. Just choose whatever is going to be the most common, and then per project this could be shifted after placement. You could choose whether you want to do that abruptly or gradually. And then if you are going to be doing gradual transition type, then you'll want to specify a transition length, and that's going to be the length that that linear transition is going to occur between the channel and the cross-section node. So you're going to create a separate prototype for each one of these different cross-section feature definitions and assign the correct conduit class and size. And then we also want to create prototypes for the from surface feature definitions. So go ahead and create new prototypes for those. And while creating these, we're going to go to the cross-section type and use from surface. And then from surface, we are going to leave all the section type information alone. That's going to populate after the node's been placed on the terrain model. But we are going to set the Manning's coefficient. So for concrete, I'll leave that at 0.013. And I'll do a gradual transition of 5 feet here as well. And then I'll go ahead and create the other one for the grass. And then set that Manning's coefficient to 0.030. Then once you have your prototypes, we're just going to simply go in and assign those to the features. Right now, thinking about existing cross-section feature definitions, I do not have any in this library. A lot of times when you're going to be modeling an existing channel or ditch, you aren't really going to need to quantify those materials, so you don't really need to have a feature definition for those, and you can just use your proposed features instead. But if you do want to show that information on your plan with a different symbology, then of course you would want to create separate feature definitions for those. But as far as the prototypes go, there is no reason to create existing cross-section prototypes, as those are not going to be designed anyhow. The only reason you might consider doing that is if you want to change the Manning's coefficient for those existing channels.